glad to be the last presentation of the evening, and this is the Mixiply Scene project. We just went through all of our names, but I'm Ronan, we've got Sefu, Gia, Alice, Bobby, and Emma. And so what is, well, sorry, I went a slide ahead. This is the introduction, some of the topics that we're going to cover throughout this. And so we're going into what is the Mixiply Scene project. It is a lightweight, scriptable, sandbox 3D modeling engine. That means that it loads quickly, it is able to be interacted with through JavaScript, and that sandbox means that it is loading items within a overall page, and that entire page isn't refreshing. We worked with Jim Taylor from Theta on this, and there were also, as you've seen, 2 other teams that were doing this. And one thing we reflected on is that we were all separately building components that were part of a larger project, which is not the kind of work we're used to in this class, but it's very much reflective of what our actual careers will be like. And so our task was to port the existing Unity-based Scene app into the web using WebGL. So in its current implementation, Scene runs on a desktop or a mobile app that's built on a Unity engine. And for users, which as we noted, they're ages 11 to 18, if they want to create an experiment with Scene, they have to browse away from what they're currently working on, download the app, get things loaded. And so, yeah, the app is free, but to us that is a deterrent. We want you to be able to do everything in one place. So what we've done is transition to a browser-based WebGL iteration of Scene. We wanted to maintain the same or improve upon the capabilities of the current app. We want to capitalize on the growing potential of web technologies, and we had 2 possible ways to achieve this. One was that we could port over the existing code, or we could start fresh with a new implementation directly in WebGL. Which one do we choose? We went with a fresh start. And so why did we just start over instead of porting? Well, for one reason, we wanted to future-proof this. WebGL is newer, it's more lightweight than Unity, and we anticipate that there's going to be more support in that direction going forward. We also wanted extensibility. Our framework can incorporate more advanced JavaScript libraries. There's no need for code translators to slow down the processes. Then, for software development best practices, we want to give the future people who are working on this code cleaner code to work with. And so next, I'm going to turn it over to Sefu to talk about our project requirements.
Thanks, Rona. So I'm going to present you our how we choose this technical stack. And before that, there's some project requirements from the client side because we have to take into consideration those 5 points. I'm not go over all of it. I'm just mention some typical things like extensibility. We have to extend the whole system after we work for 3 weeks. Some people will take over the work. We must make sure it's extensible. So the other thing is like kind of like user experience, because our end user is kids and students, so we have to make it more user friendly. That is the final product. We made it so far. As you can see, we got it IDE on the left hand side and got a canvas, 3D canvas. I will explain you guys more details on the demo. That is technical stack we choose. On the left hand panel, we got our technical stack deprecated. That is from the deprecated Mixiply implementation that customer having so far. We got the ASP.NET as the backend server. Then for the client application that is built on Microsoft Windows, Android, or iOS. Then for the rendering stuff, we got the OpenGL DirectX, different from the, depends on the operating system, that is for the graphics APIs. And then we built our application on the top of it, those APIs using Unity. So the customer eventually will use the JavaScript to talk to the Unity. So in between, we got an interpreter to translate the JavaScript into C#, because C# Unity is using the C# for scripting. Then we got a new decision to take down the Unity and to do it with all the things on the web. So we might need to choose between the Babylon.js or three.js. There are 2 different kinds of 3D renderer based on the WebGL. So finally we choose the three.js for the extensibility of AR, VR, because three.js natively support those 2 functions. That is our choice. And eventually we got the Canon ES and three.js. They're based on WebGL and Tyra on the top of Canon ES and three.js. And my colleagues will explain it more to you guys later on. So let's just focus on the next to the security concerns. So customers do have another security concern because they have some cases like the user will type some illegal JavaScript to the online IDE. That the illegal JavaScript or illegal input will disrupt or corrupt the whole web page. The whole web page will go panic for the reason of that. So we decided to implement the iframe. It's like working like a sandbox, just like Lorna mentioned before. So then let's move into another question is what if we have our two clients, one is React and one is iframe inside the React component. So what if we're gonna sync the data from the React scene builder to the iframe? So we decided to use the signal R. It's based on the WebSocket. It's kind of establishing the connection between the client side and the web server backend side. We got two connections, one from the React scene builder to the backend, and the other one is from the backend to the iframe. We got two WebSocket connections based on the signal R. And then I will pass it on to the Jeff for more explanation on three.js.
So let me talk about the first 3D render, three.js. Three.js is a JavaScript library, and it's used to creating or displaying 3D graphics on the web. And it is a high-level abstraction over WebGL and a low-level graphics API. For the developer, we can create simple geometric shapes and set its colors, and implements animations effects using three.js. And this is a simple and shows a cube and set its color to green and set its animation, the rotation X and Y. And the developer also can run 3D models in GLB and GLTF formats. Three.js simplifies complex tasks like scene creation, camera management, and lighting. And it can simply load GLB or GLTF and object manipulation. So this is also a demo and show how to load the GLB file here. Three.js is completely with most modern web borders. So next, let Bobby continue to talk about other 3D rendering.
So Canon ES is a lightweight and easy to use 3D physics engine for the web. It is written purely in JavaScript, so it pairs very well with three.js. And it's based upon established physics engines already, like Ammo.js and Bullet Physics Engine. And Bullet Physics Engine is an engine that's used in film, 3D modeling, and video games, but that's written in C++, and so Canon converts that into JavaScript. It is also inspired by the three.js simple API, so all of the functions and the methods are very simple, very easy to use for the end user. And it is purpose-built to be used alongside three.js, so a lot of the functions work together with each other. So it made it the perfect choice for the scene project. And then moving on to the Taro game engine, it is an open source, lightweight 3D game engine for the web, built with three.js and Canon ES. So it takes three.js and Canon ES and takes those methods and compiles them all into one component system, which is the entity component system. So it allows you to take things like a box geometry or a sphere, and then like a camera, lighting and shadow, and puts them all into one component in one class. So when the developers are writing their scripts, it's much more streamlined and far simpler. And then that's fully integrated with Canon ES's physics system as well. So the rigid bodies, the shapes, everything works nice and neatly together. And it is very thin, lightweight framework on top of three.js, so it doesn't affect performance at all, which is perfect for 3D modeling, especially in WebGL. And also, Tower allows future developers to extend the features of Mixiply's scene component. So that means doing stuff like sound and scripts for game design behaviors, all using JavaScript. So that means they can create fully functioning games within a WebGL framework, so on the web, just in the web app, without needing to download any external applications. Yeah, and moving on.
Now let's talk about the spreader and iframe components. The spreader is the line in the screen that can move around to resize those two parts of code editor and the scenes, and also cover invisible device to implement our mouse if go into the iframe and the spreader lose control. And for the iframe component, they will react to the size itself, the size of itself, and try to reload the page inside the iframe. And when I get those original Taro 3D code from the Goja and the Bobby, and I will turn it to the API for the code editor, and create a simple way for those people cannot use JavaScript code to create a module. So there is the other way to create a module. And we also have IntelliSense for ID, and there is for using C# to create a reminding for those people when they are trying to tie in the code. Demo.
So thanks, Rob. So I'm gonna show you guys a demo of our website. So as you can see on the screen, I got here the left-hand panel, online editor, and got on the right-hand side 3D canvas. So I got several tabs under the left-hand panel. The first one is the scene builder. It's just based on the UI controller, so user can the entry user can just use the scene builder to add some new cubes or new other entities to the frame. And the second tab is the script. It's for relatively more advanced user to using our Mixiply API to get control of the right-hand side panel. And we got this script, the Mixiply API, they are imported from, you can see we got an import map here to define the imports. And those HTML and script, they are saved in the database. We got a table for saving those HTML scripts. And that is, you can see from the final spreadsheet, we got the HTML and script, they are saving in the database, they are tagged with the sync token. So when you click on the apply, it will basically send another version of the HTML or script to the remote database. So let me show you how to use this one. So conceptually, I'm just gonna to add something here. I can add a new ball, and you can see the IntelliSense, the code compression is working with some hints to implies you to input some specific parameters. The first one is the color. Here I'm going to input a specific color based on the XR format. Then I'm going to pass it the coordinators. So here should be the X, Y, and the final one is the gravity. So I'm gonna set it to true, so the gravity will be working on the entity. So I click on apply. You can see there are several balls that are falling down, and if I click on here the 3 team, and you can also see the collection, the ball is bouncing because of the collection. So as I just show you guys, I can click on this frame and get into the iframe. So you can use the WASD to change your camera's location and move your mouse for different angle. And we also have a function called add 3D module. It's like you can add a GLB 3D module into the iframe, and in this case we add a camera for the demo. So more about the sim builder itself. The sim builder, like I show you guys, it is connecting to the ASP.NET through the WebSocket or Signal R. So when you click on the position changer, it will change the position of your it will change your position of these specific elements to another place. So when I click on the delete one, it will disappear. So that is basically about our work. So let's pass it on to the next slide. So we've got noticed some specific bugs inside our project because we go for agile development. So we are not going to fix all of the bugs after we finish all of our development. We are fixing the bugs on the fly, on the go. So we use the kind of specific website called Jira to register every bug we face and to fix every bug we need to resolve. And I'm not gonna list all of bugs we encounter. I just list some typical one for you guys. The first one is like Lando mentioned before. We got the iframe issue. So every time you drag the iframe, you may notice the iframe inside is missing the components from the sim builder. And another unresolved bug is after specific of time. So when you're loading the our sim builder or our scene components, the will be some issue in between the signal R. So you've got the HTTP 500 return. So maybe some connection errors in between the signal R and the user's client. So let's pass it on to the Alice for the scope.
Sure. So when we first started this project, the scope was quite large. I think we thought there were 6 sprints. But we revised with the client and we shrunk it so that we could still complete a product that allowed future developers to still work on it and we get all the minimal viable products for as many tasks as possible, which we did. And yeah, we just wanted to make sure everything was finished that we attempted. So throughout this project, we obviously achieved quite a lot. You saw through the demo and the technical decisions, we got the advanced user interface working. So the scripting part is the advanced user interface. So for more advanced children who know how to code, that they can do that, they can test it out. And then the beginner user interface will be in the future like buttons like add sphere, add this, change color with sliders. So it's a lot more doable for the beginners. We got the API set up and running. We got proof of concept for the beginner user face, like I said, so we can add a shape, change the coordinates, and their live collaboration, like the Canvas script, if it's on 2 screens, things will update real time. WASD and mouse to move perspective, and we made sure to make all technical decisions to like enable future enhancements like we touched on earlier. The challenges were similar with all the groups. It's like everything's new to us, so working in the agile methodology was new. Working in such a big and pre-existing project was new, and reading other people's code as well. And then just lots of languages and libraries we had to end up learning. So with what we've delivered is a very basic implementation of everything, but it's like a really good base for some exciting things. So in the future, the beginner user will be able to like add shapes with buttons like I mentioned, have color changing tools readily accessible, and add things like backgrounds and other things like that. Upload model files, and then using the mouse to click on a say sphere and move it across the screen like that rather than just doing XY coordinates. And then a really cool feature that was mentioned in our technical brief was incorporating OpenAI so children and users will be able to like speak to create basically things. Obviously it was a bit outside of our scope for this project. But yeah, we'll just be using ChatGPT and integrating it with the Mixiply API. And then I'm not sure if we ended up mentioning, but we chose, was it three.js for its capabilities to potentially do AR and VR things. So that could be like way down the line, really cool enhancement to do. But yeah, basically we're really happy with what we did, and we're really excited to see like where it will go, because it's quite a cool tool for children to learn, maybe even how to code, and like with a really cool visual tool. Yeah, thank you.
That's great. It's yeah, it's going to be a really good foundation to build on that, because sometimes you only need to prove one thing. Like you've got a script there, you can do it at cube, or you can start just extending that and running away with it. Quite often at this stage, just proving the concept and getting it to work is the first hurdle and the hardest bit. So what would you say from a technical side, where like any new skills or languages or ideas that you picked up through working on this that you found interesting or challenging?
I think the most challenging idea from the new library is the implementation of the signal R, because I haven't touched that stuff yet. And even if I just don't as responsible for the direct signal R codings, but I did use the implementation from Gene by using the signal R export libraries from Gene. But I found it's kind of tricky when I connect to the signal R hub, because I have no ideas about what is a signal hub is. So how can I fetch the initial data? So that is maybe the tricky part for me. So.
Yeah, and for me, like 3D modeling and physics specifically as well, and how they come together is also quite challenging, especially with like lighting and shadow, and then creating like rigid bodies and shapes for those bodies, and then making sure they align with like what's visually represented on the screen. That was all very challenging, but like super interesting. Yeah.
Yeah, it's similar for me, because I'm very much front-end development, so I was like, oh cool, we're going to be working with React and JavaScript, and then it's like getting that to communicate with the back-end was kind of a nightmare.
Mine's very like broad, just like literally everything was a learning point in this project. So like learning how to even navigate a repository that exists already, or like learning how to make a technical decision itself, because I don't think we've really done that before. Like maybe in our Precise project that is very small scale, but having to research things and then justify why you're choosing things, and like trying to make sure it is actually the best thing, and not just like, yeah, this will work for now and it has to work in the future as well. So yeah, I guess everything.
I think it's a common theme for us in junior developers and grads joining, is when they're faced with some of the solutions and code bases that we work with, the kind of like look of shock, oh crikey.
Yeah.
It is a skill that you get to grips with. So I guess it's the same as other things, like don't stress.
Yeah.
You'll get there. But yeah, it's really good.
I'm happy that you mentioned something like that. Oh, come on now. That's a question. No, it's more statement. I was going to have a question about the interview talking about the, of course, this is for the benefits. The scripting on the side. Because I was like, whoa! I'm interpretation group, and I could see that would be very challenging for most children. So I was happy that was kind of just a proof of concept.
Yeah, that was probably the easier thing for us to implement first. That's why it works. And then the second thing, obviously the beginner kid, which will probably be the most used part of the thing. But Jim wanted to accommodate kids who were more curious and like more skilled, and actually let them do what they want to do and not limit them.
Have you thought about how that would look, or is that beyond where you got to?
We did think about it. but yeah, not that. we were kind of more just like the content of it, so adding a sphere, adding a pyramid, and then having maybe sliders for hues or colors and like sizing and depth, like rotation, rather than having to type in anything. It would just be all button and slider based, or drop down, or yeah.
Yeah, I was saying in the brief that for every class of say 20 students, there's one or two that will want to dive into that coding tab.
Yeah, absolutely.
And that's what that's for.
That's probably a high number. It's probably more like 0 or 1.
Yeah.
Yeah.
Yeah, in the group that we work with, which is the mini devs, they're already self-selecting quite
Yeah.
digitally savvy anyway.
Yeah.
And in this implementation, we've got the beginning proof of functional concept that shows, yes, we can build a UI to do something.
Exactly. Next step is do something that Lego would do, like blocks or something, block coloring or something like that. But, yeah, no, cool, excellent. Thank you very much.